Doop.
Alright, so today we're going to be working on problem 1.42. This problem references vector A and B in problem 1.38, which I put here. These are just the vectors that I grabbed from that problem. And the question we're answering is we want to find the scalar product. Whenever it says scalar product, what it really wants is the dot product between A and B, A dot B. And we know that it's the dot product because scalar is just looking for a number and the dot product gives us a number. So we know that the dot product of A and B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. Now you could also write this in its composite form, which we will because we're going to actually use both equations today. That A dot B equals the x component of A times the x component of B plus the y component of A times the y component of B plus, if we're working in 3 dimensions, but these are 2-dimensional vectors, so we won't worry about it, is the A component in the z direction plus the z component of B. Now, if it's a 2-dimensional vector, you could write on the z part, but it would just be 0. Because here we have the x component, that's the y component, and we could put plus 0k, and that would be the same thing. But we're just not going to worry about that. So, first, since we already have the composite form here, we're going to use our composite formula. So we can find A dot B by plugging those in, which we take A, the x component is 4.00, times the x component of B, which is 5.00, plus the y component of A times the y component of B. Now, if we do a little bit of math, we have each of these has 3 significant figures, so this is going to give us 3 significant figures out here, so it's going to be 20.0. You need to watch your significant figures, especially at the end. And then we have a negative here, so that's minus 14. We have 3 significant figures. 0.0 gives us 6. And we can have 2 leading zeros, giving us 3 sig figs. Alright, so that is the scalar product, or the dot product, between A and B. So that's one of our answers. Now what we've got to do is we've got to find the angle between them. Because if we draw this out, A is a positive vector in the x direction, positive in the y direction, so it'll have a positive slope. B is positive in the x direction, but negative in the y direction. So we're going to get a slope kind of like that. And so that's A, B, and we want to find this angle between them. Now the way we can do that is we can use our other dot product formula. So we already have A dot B, we know that part. To use this formula, we need to find the magnitude of A and the magnitude of B. So we can do that using the Pythagorean theorem, because as we know, the magnitude would be the length of the vector, and we have a triangle here. We can just use the x component squared plus the y component squared. That'll give us the magnitude squared. So the magnitude of A is equal to the x component of A squared plus the y component of a squared, which is going to give us 16.0 plus 49.0, watching my significant figures, and that's going to be, so we got here, I wrote this down here, 65, that's right. So we have 65.0. But we still have the squared over here, so if we want to square root both sides, we can get the magnitude of A is equal to the square root of 65.0. We can do the same thing, find the magnitude of B. It's equal to, of course, the magnitude of B squared is equal to 5.00 squared plus, now you got to watch your parentheses because we're squaring this component and it's going to actually come out to be positive. So we get the magnitude of B equals, going to square root both sides, 25.0 plus 4.00 equals square root of 29.0. So we can get three significant figures out of here because our inputs both have three significant figures. Alright, so we have the magnitude of B, we have the magnitude of A, we know the dot product, now we can just plug it into the formula. Now if we do that, what we end up getting, we have the dot product of A and B, which we have here is 6.00 equals magnitude of A, which is square root of 65.0 times square root of 29.0. Ran out of room there. I'm going to rewrite this. Times the cosine of theta. Now what I'm actually going to do is I'm going to divide these two terms over to the other side. I'm going to flop it here. I'm just changing the order so that we can see it a little differently with theta on this side. And I'm going to divide these over to here. So what we have is 6.00 divided by square root of 65.0 times the square root of 29.0. And then we can take the inverse sine of both sides to get rid of the cosine. And you have this lovely number to plug into your calculator and get a value. And if we plug that into the calculator, at least when I did it, what we get is 90. So the theta is equal to 90 degrees. So apparently these two vectors form a right triangle. So that is problem 1.42. We found the dot product, which was 6.00. We found the angle between them, 90 degrees.